Hi, so in this session I am going to tell you about how can we make our own exceptions. So there can be custom exceptions as well, but before going into that we are going to learn that if we have to raise any exception ourselves, if we have to raise any exception, the code is not giving an exception but we want to raise any exception. Okay, so we can raise any exception by ourselves. Let's say here if I take numerator and denominator, and if denominator is taken as a 0, I have not performed division operation until now. I will handle here like if denominator has been given as 0, something like this. So I will not perform this operation value is equal to numerator divided by denominator. In fact, I can raise my own exception using the keyword raise. Okay, I can raise an exception. I can raise a 0 division error. Let's say I have multiple exceptions which are inbuilt exceptions. I am just raising 0 division error, something like this. And if I do this, if I am doing this print hi, enter the denominator 5 and 0 I have specified. So here I got denominator should not be 0. So I have handled 0 division error. I have not printed high. Initially when I had not written this, so I was getting in exception in this numerator divided by denominator. So I am getting 0 division error using this line previously. But now since I have done here denominator equal to 0, so I am raising 0 division error, so it is handled here. So that's why it is coming because of this error. It is not coming because of this division, it is coming because of this. So let's say I am not raising 0 division error, I am raising name error, something like this. I have not handled that exception name error, and if I now try to run this 5 and 0, so I will get an error that raise name error. So name error has been raised. Okay, so you can raise your own raise the exception yourself as well by using the keyword raise. It will just throw an exception, it will just raise an exception. You have not handled that exception, that's why you are not coming here. If you had handled 0 division error here, it was running this code, you are given as 0, 5 as a numerator, 0 as a denominator. Yeah, it was running this code. If denominator equal to 0, yes, it is equal to 0, it has raised 0 division error. In this block the output is a division error has been raised, so it comes out of this, it will see this, it is not value error, it will see this, it's a 0 division error. Okay, it has printed denominator should not be 0. If you had raised name error, then it has come out of this code, it was not value error, it was not 0 division error, it has just raised that exception. Okay, so this is how the code is running, and you can raise your own raise the exception by yourself as well. Okay, now here it doesn't make sense of 0 division error. Here actually the exception should be 0 denominator exception. Okay, you want like 0 denominator exception, 0 denominator error. So you want your own exception that is not present in Python. So you want your own exception. So what you can do is you can have a class, you know about inheritance, you can have 0 denominator error, something like this, and it is type of exception. How can you get it? You will inherit from exception class. This is an inbuilt Python class. Here I am just passing here, I am just not writing any code here. I can have an init function, I can have my own constructor, but in the exception there is a inbuilt constructor as well where you can specify your own message. Okay, so there can be other arguments as well, but the most important argument is message. You can specify your own message, so you can raise your own exception by here 0 denominator here. Here it makes sense to print 0 denominator error. Here you can print a message here that denominator should not be 0, something like this, and 0 division error means division by 0 is not allowed, something like this you can do. If 0 division error comes, you are printing this. If value error comes, you are printing this. But if denominator equal to 0, that means you have given input as numerator as 5 and 0. So denominator should not be 0. Okay, that's a concept of fraction. The denominator should not be 0. So I am not performing this operation if denominator comes out to be 0. Okay, so now if I do this, if I have raised 0 denominator here, I can have 5, 0. So I had raised my own exception, it is getting an error, exception handling.py line 12, raised 0 denominator error here, and here I am getting that main.0 denominator error, and here is your message coming that that denominator should not be 0. Okay, so this is what you are getting, and this is how you can raise your own exception. Since you can raise your own exception, that's why you can handle your own exception as well, except 0 denominator error. Like this, I can just print that what denominator should not be 0. Okay, or I can print that zero denominator error is raised, something like this. Okay, so I have handled that exception as well. Now it will not give me error, instead it will be like zero denominator error is raised. You can run the code again, because it raised the zero denominator error here. It has come to this. It is not a zero denominator error. It is not a zero denominator error. It is a zero denominator error. That's why zero denominator error is raised. So you have not break out of the loop. It will try again. Okay, it will try to ask numerator and denominator again. So this is how you can have your own exception. You can have your own exception. It can have your underscore init function as well. It will by default takes message. If you are not defining your init function, then init function exception will be called, and that's why it is getting message. If you are passing this message, then init of exception has a argument named message. So this message has been passed to that, and that's why you are able to raise the exception and print that message as well. Okay, so this is how it is working. This is how the concept of inheritance comes. This is how the concept of exception handling comes. You can raise your own exception. You can handle all the exceptions. You can handle multiple exceptions, and I think now you are comfortable while working with exceptions. Okay, great. Thank you.